U.S. Naval Observatory master clock at the tone Eastern Daylight Time, 19 hours, 42 minutes, 45 seconds. Universal Time, 23 hours, 42 minutes, 50 seconds.
Feel free to open your cell phones and look at what time your cell phone is.
U.S. Naval Observatory master clock at the tone Eastern Daylight Time, 19 hours, 43 minutes, exactly. Universal Time, 23 hours, 43 minutes, 5 seconds. U.S. Naval Observatory master clock at the...
So what you were just listening to there was a digitized voice representation of these 80-some clocks. 80 clocks. They average 80 clocks. 57 of these cesium clocks, 24 hydrogen masers. So it's like a laser, except it's a maser. And then they got a bunch of backups as well. So it's accurate. So the next gen of these is accurate by 10 to the minus 16. 7 times 10 to the minus 16 is how accurate the clocks know the time. And that is why you can figure out your GPS location to within 2 centimeters. Cool. Or not. Cool for me. That's like,
right. I think I read somewhere that you mentioned Solo's book. Captain Cook, I guess he tried to estimate how wide North America was, and I think he was only off by like a couple hundred miles by using celestial coordinates.
yeah. Yeah, but I mean,
As far as the plot.
by far the easiest thing to do celestial navigation with is the sun. If you looked at those books as they went around, it gives, I don't know how many different stars in there, and it gives like really, really good navigators can use multiple different things. The sun is just, sun's like the basic one. So if you ever wanted to get a sextant or borrow mine or borrow somebody else's and see if you could figure out how to get a sun sign. By the way, I know of one place, I know of a couple places around here where you can see a natural horizon. You can see a natural horizon from Greenwich Beach, right? So if you go to Todd's Point and look east, you've got a natural horizon. And if you stand in the Covens property and look towards New York City, you get natural horizon before you get to the bridges. I'm sure there's a lot of other ones, but I know those two. And I'm sure Jamie and Sophie won't care if you go take a bunch of suns out. Watch out for Oscar, he's a rascally dog. All right, so we talked about the latitude and longitude element of this. So we're talking about this celestial piece here. So we've got latitude and longitude, right? Well, there is another sphere called the celestial sphere that has, and if you looked, you saw the term GHA, which stands for Greenwich Hour Angle. And then there's another term called declination. You'll hear people talk about the declination of a star, declination of the moon, and that's basically latitude. So if you can imagine, we've got the Earth at the center, and then it's an imaginary sphere, because once something is a few thousand miles away from Earth, it doesn't matter where you're looking at, the East Coast or West Coast, it's going to look like it's at the same point in the sky, let alone stuff that's light years away, right? And so there's this imaginary sphere that any celestial body can be measured by GHA, Greenwich Hour Angle, which basically is how far east or west it is from the prime meridian at some point in time, and declination, how far positive north or negative south it is. This, by the way, if you pass the book around, this is what one of these site reduction charts looks like, and knows what it says here, right? So everything is given as a basis of Aries. I won't go into the history of that, but if you think about astrology, like the first sign was Aries, right? That's the first sign in the astrology calendar. So that's what when the ancient Greeks, or even before that, were figuring out how to do, that was the first point of reference that they had for doing something. And they didn't think Aries moved, right? Because they thought that we moved around it. So you still see stuff, based on Aries in these. So someone asked how a sextant works. So that's actually a picture of a sextant very similar to the one that's being passed around. And if you didn't play with it, when you look through a sextant, there's actually two halves. So mine is actually calibrated because I've used it recently. So if you had this at 0 and you didn't turn this little knob here, the fine control, and you looked out at the horizon, like if you looked at that horizon right over there with it, it should look like one horizon. You know? But if you moved the arm down at the bottom, right? So like you can see here how this arm's been moved, all of a sudden you'll see half of the mirror split, right? And so all a sextant does is by adjusting this arm here, you bring whatever celestial body you're looking to till it sets right on the horizon. That's what a sextant does, right? And, you know, there's all kinds of little details in this that we're not going to go through. But mine is actually swung pretty good too. So if you were to take mine and look at the horizon and then swing it left and right like this, if it's not calibrated, the horizon will look like it goes like this. Yeah, it looks like it goes like this, right? Whereas if you look at, mine goes like that, like you would expect. It's almost like there's no mirror there, right? So you do that by adjusting the little screws. So once you get it calibrated, then you're able to take the side screw accurately. So there's another site that's worth checking out if you want to. So this is a copy of today's date out of that red book that's going around. And this is this is the copy of the red book that's going around. This is off of the website called nauticalalmanac.com. So if you ever want to, you know, if you ever want to play around with this stuff, there's a website, nauticalalmanac.com, that has all of the up-to-date, as a matter of fact, you can get it out to 2050. And because it's digital, right, they have it for the exact year. So see, this is 2017, June 3rd to 5th. And I have highlighted down here, I'll explain why I have this highlighted, but this is Monday, that's today, so this is June 5th, right? In that book, the June 5th that's over here, is, that little book covers 2000, is it 2000 or 2010?
50 years.
Yeah, so it covers 50 years of data. So basically there's patterns, and so that big 1 up there means that in 2017, if you divide by 4, right, 2017 is a 4 with a carry of 1. So 2017 divided by 4 is 4 with a carry of 1. So you go to the table 1, and it talks you through how to do all this. It's too much detail. But what I do want to say is, so imagine I took a local noon site day. Now I couldn't take a local noon site because it was cloudy, right? But I have an app on my phone that tells me what local noon site for my exact latitude and longitude it is. Right? So I popped it in and I said, okay, 12:52:54, right, which was 16:52:54 at the prime meridian, right? The Nautical Almanac tells me that for 16 hours, the sun has traveled 60 degrees, 21.6 minutes. Why is it not exactly 60 degrees? Well, guess what? The prime meridian is not really the prime meridian every day of the year. Matter of fact, rarely is it exactly the prime meridian. At high noon, at 12 o'clock exactly, the sun is not over the prime meridian. It's either east or west of it a little bit. Matter of fact, today, it was west of it by 21.6 minutes. Was how far west the sun was at 12 noon of 0 degrees longitude. Did your mind hurt yet? Go through a conversion process, and basically the noon site that I came up with is 7335.1, which is pretty darn close to the longitude of my house. So I just went through the steps that are outlined there, and I'm happy to offline explain to somebody how this works. But I think you get the concept, right? I said that the prime meridian is at 12 noon is actually 21.6 minutes west. So the sun is actually not right here. The sun is a little bit here, right? So the Earth rotates this way. And so here's 1 hour, 2 hours, 3 hours, 4 hours, and then 52 minutes and 54 seconds, which is my quote-unquote site above me, right? And then the reduction, just by the simple math, got me to this number, which calculates out to 7335.1. And that's how you do celestial navigation. It's not that hard, right? I mean, it's math. In the same way, right, if I knew what the inclination of today is on June 5th, matter of fact, it probably tells me here. So the sun today, the declination at 16 is 22 minutes 36.0 seconds. So it tells me where the sun is. So if I knew the angle to the sun as well, which I didn't record, so from that one side I can figure out latitude and longitude. Make sense? Questions? That's as much as we're going to get into celestial navigation.
Why
But,
did they use planets?
huh?
It's just, there's like 38 stars in the book, but how come they didn't use planets?
Well, some of them are planets.
Oh, okay.
Yeah, you can do, it all depends on what reference you want to do. Right. And it just adds one more level of complexity to the map, because when you're using something other than a local noon site, you also have to adjust for for the Greenwich hour angle, east or west of where you are. So it's just one more level of complexity. So I just wanted to do this to give the basic concept of it, so that you understand what's happening to the moon and stars and sun as we're here, but also as a point of reference to say, I've never lost at sea. This is maybe good information. Right? Yeah?
Yes.
Questions?
So I have a question.
Yeah.
We changed our fallback time.
Mm-hmm.
Did they change all those books?
Those books are all to UTC, which does not change.
Oh,
So GMT changes.
yes.
UTC does not change. There is no daylight saving time for UTC. It is always the same.
Oh,
So what you have to do, so the correction, so the page where I had that 12:52:54 was 16:52:54.
yes.
I have to take into account that we are on daylight saving time right now, and therefore we're UTC -4. Not if I took that same noon site on December 5th, when we are not on daylight saving time, and therefore we'd be UTC -5. That makes sense? I still get confused about daylight saving time. I really do. It's I always have to stop and think, because it's not
We're in it now.
correct. We're in
Spring
daylight.
to fall, we're in it.
Correct.
Then fall to fall back.
Yeah.
Fall
I think. I don't know that. I don't know about that. All I know is, I don't know that. All I know is we're UTC -4. That I know. That much I know. Okay. If you've got your chart, whip your chart out.
Yes.
Yeah, that's correct. So in this exercise, so we've talked about dead reckoning, and we've talked about celestial. So now we're going to talk a little bit about piloting or pilotage, okay? Just to get the concept here. So I'm going to talk about a couple of things that I haven't gone into the detail to explain. I'm going to make some assumptions in the next 10 minutes or so that you know some things about the nautical chart that we haven't talked about yet. So just bear with me, because we'll come back and then talk about the nautical chart in detail. But this is a image of basically the area around Long Sand Shoal. Okay? So that's on the the eastern part of this chart. So out kind of towards the right-hand side. So, does everybody have something like this?
Can we just say because we missed it right at the top?
Yes, you may. And if you have a newer version, it's fine. Because for this exercise, actually go back a bit. That doesn't matter. It's fine. Okay. So I'm going to give you 3 pieces of information. The first piece of information is, so we're out in the Sound, we're going along, and we want to figure out where we are, and we want to use the methodology of pilotage to do so. So what we're going to do is we're going to get out a hand-bearing compass. Here's 3. I'll pass around so you can look at hand-bearing compasses. I'll have some images of that in a minute. I see hand-bearing compass brush at Amazon or Landfall.
There you go.
I have a couple more that actually, I have one that I like a lot better, but I couldn't find one. So imagine that you were to take, that you were to recreate this line that I've drawn. So it says B305M. What do you think that means? Bearing. 305M. 305 magnetic, exactly. And so we've used our hand-bearing compass to say, I can see this gong right here, R8A. I can see it, and I took a sight off of my hand-bearing compass, and it was 305 degrees magnetic, right? So how would you chart this line of position? So I'll try and do it with this. So there's a compass rose here. Should be in the same place on yours, basically. And it has 2 numerical compasses on it. The outside one with the star is true, and the inside one, the smaller one, is magnetic, and it says magnetic here. Okay. Again, don't worry about true versus magnetic. We're going to explain that in a little while. So this is part of we're making a leap. So if you could imagine, there's no way I'm going to be able to do this, but if I could take this divider, see how I've got it on the chart, and I'm holding it at 305, right? If I was then able to walk across like this to that mark, right? And if I had kept whichever side I wasn't moving down on the paper the whole time, guess what? I'd have a line here that's 305 that I could draw like a little dash line or just kind of a light line if you want to. Some people have, I don't actually have one of these because I actually personally don't like them very much, but some of them have it's a ruler that kind of looks a little bit like a triangle top that has a roller on the bottom of it. And so what you can do is you can twist the top part of it and then you can roll it along the page. I've found them not to be very accurate. This is one I actually do kind of like. It's got, I don't know if you can see, it's got a protractor in the middle of it, right? And so the idea here is you look at what the variation is, magnetic variation, which says it's 15.1. And so what I can do is I can put this any place on these old charts have the Loran lines on them too, so it's kind of hard to figure out which is which. So I think this is a latitude, it doesn't matter. But you can figure out what latitude and longitude line is, and you can put it here, and you could read off of it then what the actual compass bearing is. So I like these, just not very well on a big chart like that. So were you able to find this mark? So see if you can find that mark and draw a line 305 or reciprocal of 305, which is, how do you find the reciprocal of 305? So we're doing magnetic. So we put this, here's 270, this is 310, 320, 330. Put this, say 305. I hold this and slide this over until I touch that mark 8 and then just draw.
The outside is magnetic, I forget.
Say again?
Inside or outside for magnetic?
Inside for magnetic.
You have to just
What's your bearing 305?
So it has to be on this line.
Okay. It's one line of
Something like that.
Okay, so you've got one of them. Okay, that's it. I like it.
A buoy.
So what we're going to do is we're going to put 305. What's this variation?
Has to be here.
So you're going to put
It
305.
says 305. 305 could be anything that runs over here.
So what that means is you have any one of these lines,
That way is from the
any
west.
see how this is line is online, latitude or longitude here. Right? That's why I like this there. I like the interface to this also. So there's your one, so there's your this is the other way to do it.
So if we could say 125.
You have to set it to variation of the charge. Versus the 305.
That's your first point.
Only do it when you have these.
Well, if you're on the chart, you have to say, okay, that's 305, what is 305? Well, first thing you have to know is that's what we saw 305. And then you have to get it.
So you have to say, you may not want that.
So if it was here.
Or here's the logic.
Of course, you have this, it's tricky, you figure it out.
That's all we know. This is go to the center across there. You'll find hold down on this one. And move this
And then you have to walk
right there.
So there'll be a test
But this is how you keep marking line of flip. That's why it's anytime you do R8, unless you get because obviously the next thing is okay. So the way to figure out how I get is another one that's a triangle, right? So you have to say, okay, say it's here. If you can see this, you're probably seeing that. And if this were, if you said, I can see this, that, just say, you can see So, say I saw that at 30 degrees, right? Oh, that's 30. Walk down.
Yes. That tells you how far the motor
Well, this is the only place where this, if you look here, this is 305.
All right, so I've had a request. I have everyone's attention for a second. So I've had a request to make the next step so that you can understand. So back to what I said. So we're on a boat. We see this mark here, okay, and we put our hand-bearing compass on. So imagine I'm going down the sound, so basically this direction, and I say, well, I can see a mark back here. Let me put my hand-bearing compass on it. It measures 305. That in and of itself tells us not too much, right? So the exercise we're going to do is there's actually two more lines of position that I'm going to give you that says, at the same time that you get this bearing of 305, you're going to look at the lighthouse up here and you're going to say that lighthouse bears 20 magnetic, and Red Gong 8 at the eastern end of Long Sand Shoal bears 49. So you're going to actually draw three. These are called lines of position. Whoop, I went the wrong way.
Assuming I am wearing my boat, or does it not matter?
Huh?
Assuming I am wearing my boat at this point.
You're trying to answer the question of where you are,
Okay.
right? And guess where you're going to be? Once you graph this,
Yeah, at that.
you're going to be at the intersection of those. Now you could just graph two of them, but the accuracy is not as good. So when you do lines of position, you always do three. Okay?
And then you see that goes.
So the exercise we're doing is I'd like everyone to try and graph these three lines
Okay, so then that's the lighthouse, right?
and see where they intersect.
You want to do magnetic or true?
What's it say up here? Magnetic. And why do you do stuff in magnetic? So let me ask a question. Where's the hand-bearing compass? One of the hand-bearing compasses.
This is going to be your.
So if I'm looking through this hand-bearing compass, what is the number that I see here? Is it magnetic or true?
Magnetic.
Correct. So the majority of stuff that you'll do in magnetic. Right. So I run my GPS in magnetic. Everything I do is I do in magnetic. The only place you have to be conscious of magnetic and true is when you go to chart.
Are we just assuming at this stage that this is magnetic?
What is it?
Are we assuming that this road is not 49?
Yeah, we're assuming that there's zero deviation.
Right, zero deviation.
I haven't explained to you deviation variation yet, so I apologize. But assume that this is accurate magnetic. Yeah.
So what is
Set the mark.
So the next one.
So what you do when you're doing this is the way you write it. You put it on now we call it
So hold this one and run off the lighthouse. Get down to the center of that bounds right there. And what I would actually, what I would do if I was doing this on a chart is I would actually write exactly what I wrote up there. Because I want to be able to distinguish when I look at the chart that this is a line of position and not my heading, right? And so it's typically drawn as a very light line, and it has this nomenclature, B, because you've taken a bearing on something, right? And why is this 305 as opposed to 305 minus 180, which would be the reciprocal, right? Because we're here, and we're looking to the northwest, and so our compass says 305. Yes, Kathleen? Look, I have my glasses. So hold on this side.
Oh, yeah, so what, oh, yeah. You're seeing 49 at this point, you're seeing 49, so walk.
Somewhere on this
Sorry, 49, sorry.
49 is
So one of them, they're hitting, we're going to the center of the pentacle. Okay, so everybody has a compass on it. This is all in your head, so you're looking through the head, and you say, oh, I see that mark over there. You're trying to figure out where you're going. So the next one is from the light base. I'm going to do a pairing.
So you use the
And this is all when you right. You're zero look at it. 49. You're looking to
and then after we do that, you got to figure out that next 330. So that minus 49. And you're right in that. But then you know you're going to be below that.
And then the last one is 49. This red. So you want to get these through it
So
first,
And then we don't lock it in yet, because you're, this is.
So my hunch from me going around this exercise is that the whole thing